Good morning, everyone. My name is Patricia Gavotti. I'm a senior geophysicist with Canacol Energy, and I'm very happy here to present you this talk titled Aguas Vivas Field, a significant new gas discovery hidden for over 70 years of exploration history in the Lower Magdalena Valley Basin, Colombia. This is the outline of my presentation. I'm going to start with a brief introduction, and then we will cover the exploration history between the years 1945 and 2015, specifically in the blocks Esperanza and BIM 21. Then we will review the Aguas Vivas gas discovery with a discussion of all the wells drilled in the area, then a field production update, summary and conclusions, and acknowledgements. The image on the right side shows a beautiful flame from the Aguas Vivas 1 well initial test performed in June 2021, which tested 35 million standard cubic feet of gas per day. The Lower Magdalena Valley Basin is located in the northern part of Colombia onshore, and it is defined as a fork-arc basin, result of multiple episodes of subduction and accretion due to the collision of the Caribbean plate with the South American plate. It is delimited to the northwest by the Romeral Fault System, by the northeast Santa Marta and Bucaramanga Fault System and Cesar Rancheria Basin, and to the south and southwest by the Central and Western Cordillera. The basin can be subdivided into the Plateau Subbasin to the north and the San Jorge Subbasin to the south, separated by the Magangue Arch as indicated in this Bouguer anomaly map. The area of study is located in the western flank of the San Jorge Subbasin. The stratigraphy of the Lower Magdalena Valley Basin is composed from oldest to youngest by the Ciénaga de Oro Formation, followed by the Porquero Formation, then Tubara Formation, and Corpa Formation. These units are divided by four main unconformities defined as the Pre-Oligocene unconformity, Lower Miocene, Mid-Miocene, and Pliocene unconformity. Our target formation is the Ciénaga de Oro of Oligocene age, and it was deposited in a fluvial to deltaic to shallow marine environment. The deeper section is more fluvial with higher proportions of coals. Thickness varies from 1,500 to 3,000 feet, and it has a porosity range from 18 to 28%. It is composed by massive to laminated, medium to coarse-grained sandstones interbedded with limestones, coals, and shells. The image on the top shows a schematic of the basin highlighting these main units and the unconformities. In some local cases, the top of the Ciénaga de Oro Formation and the Porquero Formation has been eroded by the Mid-Miocene unconformity. In terms of trap, we look for structural traps, typically three-way fault-dependent closures. The exploration history between the years 1945 and 2015 in the Esperanza and BIM 21 blocks is summarized on this map on the right-hand side. In this area, 60 wells have been drilled on the original Hobo concession, where 41 well gas discoveries and 18 were dry. This gives an overall chance of success of 68%. The success rate without seismic or just using 2D seismic was 64%. The success rate on 3D seismic increased to 85%. And in this area, 3D seismic was acquired in the years 2007, 2009, 2010, and 2012. Some gas fields discovered using 3D seismic data are the Katana field and the Cañaflecha field, which are located in the northern part of the map, as well as the Nelson field and the Palmer field, which are located in the south. The target formation was the top of the Ciénaga de Oro, and historical practice was to drill the crest of a structure and continue through gas-bearing sandstones until the first wet sandstone was encountered and called TD. All the wells drilled in this area were pretty much vertical and none of them reached basement. In terms of sizes, we have on the smaller side the Katana and Cañaflecha field, which they have an estimated OGIP of about 5 BCF. On the larger side, we have the Nelson field with an estimated OGIP of almost 350 BCF. As a reference, the Aguas Vivas gas field is located to the south of the Coral and Cañaflecha fields in the BIM 21 block. Exploration history using 2D seismic data is represented in this slide. The map in the middle shows some of the gas fields discovered using the Gavotti 1975 2D seismic program. All these wells were drilled before the 80s, where Coral 2 and Coral 4 were gas producers. Coral 5 has gas pay, and Hobo 6, Coral 1, and Coral 7 were dry and abandoned. The image on the right is an interpretation from that time at the top of the Ciénaga de Oro formation, where you can see two gas fields highlighted, the Coral field and the Hobo field. Seismic line AB is represented on the upper left, and the seismic line goes close to the penetration point of the wells Coral 5 and Hobo 6. Coral 5 has gas pay and Hobo 6 was dry and abandoned. It was drilled down deep in this fault compartment. The XY seismic line is represented at the bottom left, and it goes close to the penetration point of the wells Coral 5 and Coral 4. Coral 4 was the producer of this field, and it was drilled at the crest of the structure. As you can see, all these wells were vertical and none of them reached basement. Again, as a reference, the Aguas Vivas field is located to the south of the Coral field in the BIM 21 block. This is a structural cross-section of the legacy wells drilled before the 80s in this area. Going from north to south, we have the wells Hobo 6, Coral 5, Coral 4, Hobo 11, and Hobo 9. You can see the correlation between the main units, and the pay flag is indicated by the red boxes. Also, the perforation zones are indicated by these green boxes. These wells encounter gas at the top of the Ciénaga de Oro formation. And as an example, the well Coral 4, which was the producer at the Coral field, had a cumulative production of 4.6 BCF. None of these wells reached basement. Canacol's activity in this area started in 2015. With the use of 3D seismic data that was reprocessed and also with the computation of AVO attributes, we were able to reinterpret the area, and we have identified 3 additional fault compartments at the top of the Ciénaga de Oro formation that were not identified before. The map on the top right shows a depth structural interpretation at the top CDO, where you can see the 3 fault compartments that were tested by the Cañahuate wells. The middle compartment was drilled by the Cañahuate 1 well in 2017. The easternmost compartment was drilled in 2018 with the Cañahuate 3 well, and the westernmost compartment was drilled in 2021 by the Cañahuate 4 well. The map at the bottom shows the fluid factor extraction at the top of the CDO, and you can see where we have very strong AVO anomalies in conformance with the structure in all the fault compartments. All these wells found gas at the top of the CDO, and the results show that each fault block is a separate pool with different gas sands and contacts. Revised seismic interpretation demonstrated previously unrecognized structural closures at deeper CDO levels. The map on the upper left shows the depth structural interpretation at a top CDO versus the map on the right side is a depth structural interpretation at the deep CDO level. This deep CDO unit sits on top of the basement, and we can see how the structure has increased to the south, where we have three-way fault-dependent closure against the main trapping fault, and we have identified this closure as the Aguas Vivas structure. The seismic line on the right side goes from the well Coral 4 to an schematic well that uses a directional plan to test the thick CDO section. And this is the way Canacol has been drilling the wells. The idea is to drill directional wells parallel to the main trapping fault to test thick accumulations in the entire CDO column. And in comparison, vertical wells like Coral 4 only worked for testing accumulations at the crest of the structure. In addition, the Cañaflecha 1 well was drilled to basement in 2008 by our predecessor. This well was completed in the upper CDO sands, and it showed a successful but modest DST in the deep CDO. And the new seismic interpretation demonstrated that Cañaflecha and the Aguas Vivas prospect both are located in the same fault compartment. So with all this indication, we decided to drill the first well in the area. So then we drilled the Aguas Vivas 1 well. The map on the upper right shows the depth structural interpretation at the deep CDO level. This deep CDO unit sits on top of the basement, as mentioned before. And the map at the bottom shows the fluid factor extraction at this level. You can see how here again we have a strong AVO anomalies in conformance with the structure. The seismic line goes along the trajectory of the Aguas Vivas 1 well and is represented on the left. And you can see how I planned the trajectory of this well to go parallel to the main trapping fault and chasing all the main AVO anomalies at different levels. The result is that we found in 412 feet TBD of net pay within the Ciénaga de Oro formation. And quoting our press release, the gas column encounter within the CDO sandstone reservoir at Aguas Vivas 1 is the thickest yet encountered by the corporation in its history and marks a significant and important new gas discovery. We then proceed to drill the Aguas Vivas 2 well. This is an appraisal well, and it was drilled to confirm the pool extension of some of the sands in the field. The map on the upper right, it's a depth structural interpretation at a mid-CDO level. This mid-CDO level is indicated by the green horizon on the seismic line. The map of the bottom right, it's the fluid factor extraction at this level, and again you can see a strong AVO anomalies in conformance with the structure. The AV seismic line goes along the trajectory of the Aguas Vivas 2 well, represented on the left-hand side, and again you can see how we did a directional well parallel to the main trapping fault, chasing all the fluid factor anomalies at different levels. We encountered 229 feet TBD of net pay in the mid and deep CDO. Petrophysical interpretation of the Aguas Vivas field is summarized in this slide. Starting on the left, we have the Aguas Vivas 1 well, followed by the Aguas Vivas 2 well, and then the Aguas Vivas 3 well. Aguas Vivas 3, it's a development well drilled in this field. We are displaying here the gamma ray, gas chromatography, resistivity, neutron density, saturation, pore volume, net pay, and the interpretation. And pretty much you can see how we have found gas in the entire CDO column. In terms of petrophysical properties, we have similar petrophysical properties in all 3 wells, with an average porosity of about 22% and an average water saturation of about 35%. In terms of net pay, Aguas Vivas 1 has the highest net pay encountered by a single well in the basin, with 412 feet TBD of net pay, followed by the Aguas Vivas 3 with 378 feet TBD, and then by Aguas Vivas 2 with 229 feet TBD. The Aguas Vivas Field structural cross-section is displayed on this slide. We start from west to east, connecting the wells Caña Flecha 1, Aguas Vivas 2, Aguas Vivas 1, and Aguas Vivas 3. The cross-section displays the correlation between the main units, and this correlation has been supported by wireline pressure data. You can see how we have different fluid contacts and that some of the sands encountered in the field are only present in the 3 Aguas Vivas wells versus a couple of others extend farther west where the Caña Flecha 1 well is. The pay flag is indicated by the red boxes, and all this information and the interpretation help us to define the completion program for these wells. Perforations zones are indicated by the green boxes, where we start perforating the Aguas Vivas 1 well at the deeper part of the CDO, followed by the Aguas Vivas 2 well where we perforated the mid CDO, and then Aguas Vivas 3 where we perforated the uppermost part of the mid CDO. Additionally, the new seismic interpretation also demonstrated exploration potential in an undrilled fault block at the mid CDO level between the Aguas Vivas and the Cañahuate 1 fault blocks. The map on the upper right is a depth structural interpretation at a mid CDO level. This mid CDO unit is represented by the green horizon on the seismic line. And you can see how the undrilled fault compartment is highlighted by this white polygon. The map at the bottom shows the fluid factor extraction at this level, and again you can see strong AVO anomalies in conformance with the structure. We tested this fault block with a well named San Marcos 1, and the seismic line on the left-hand side connects the wells Caña Flecha, Aguas Vivas, San Marcos, and Cañahuate 1. You can see how that undrilled fault block is represented and all the fluid factor anomalies are present at the mid and deep CDO level. We drilled the well San Marcos 1 and we encountered 105 TBD of net pay and similar petrophysical properties than the Aguas Vivas wells. Also, the gas sands in San Marcos 1 have different contact than the sands in the other fault blocks. In terms of production, this plot shows the field production of the 3 Aguas Vivas wells as well as San Marcos 1. The yellow boxes indicate the spot date of all these wells, and the green boxes indicate the production start date for each of the wells. Starting in June 2021, we drilled the Aguas Vivas 1 well. We start producing it at about 15 million standard cubic feet of gas per day. Then we incorporated Aguas Vivas 2 and Aguas Vivas 3, and the production bumped to about 50 million standard cubic feet per day. And also San Marcos 1 starts producing in September 2021, and all 4 wells recently have an average production of about 56 million standard cubic feet of gas per day. So in a time span of 10 months, and as of April 5th, 2022, we have a cumulative gas production of 12.2 BCF. This is a pretty impressive result in this short amount of time. In summary and conclusions, exploration activity in the 70s was based on 2D seismic data, which helped with the discovery of shallow CDO gas fields like is the case of the Coral and Hobo fields. in the Lower Magdalena Valley Basin with a chance of success of about 64%. Most recent activity incorporated 3D seismic data with AVO attributes which incremented the chance of success to 85%. Implementation of directional drilling parallel to the main trapping fault allowed for testing stacked reservoir sandstones in the thick CDO section. So the presented workflow led to the discovery of the Aguas Vivas 1 well, which encountered 412 feet TVD of net pay, highest net pay encountered by a single well in the basin, and this was only at the mid and deep CDO levels. So, with the application of detailed structural and attribute mapping, an open mind to look at new horizons, and the use of directional drilling, it has been possible to discover 100 BCF field below an area that has been explored for over 70 years. I would like to thank my Canacol team here in Calgary and also in Colombia, and Absolute Imaging for reprocessing the data used in this analysis, PetroExplorer for computing the AVO attributes, and the GeoConvention for accepting the paper in this conference. Thank you very much.